very simple properties of objects. How do we read? How do we write? How do we access things? And then today we're going to go a little bit more into depth into objects, but also move into functions as well. Functions are pretty critical, and I think there's something that we've taken for granted so far in most of the workshops, which is you write a function, the test runs it for you, and we don't really think too much about like what a function is, how do we actually run it, what happens with our multiple functions, how to create one kind of from scratch. And so between today and then both of Saturday's workshops, we're going to be diving a lot more into depth about functions and kind of how they work. So today we're talking about object methods. And just so you know, when we talk about a method, it really, like, you can think of a method as basically just a function, but it's not a function like in the wild. And so what I mean by in the wild, I mean every function that we've written so far in a workshop, right? Like if we wrote a function called crazy caps, when we call that function, we just literally write crazy caps, open parentheses, close parentheses, and we're done, right? Like we call it individually. But for a method, it's a function, except this function is tied to something. It has like an owner, as in order to call it, you need to call it on behalf of something. So for example, let's take the example we gave here, which is index of, right? Or anything that we've seen so far with like array.includes, right? Or array.push, right? I can't just write push, open parentheses, close parentheses, because JavaScript will say, well, what are you pushing to, right? Like, what push function are you accessing? We have to do array.push, right? Or this array.push, or this array.includes, or this array.indexOf. And so because of that distinction, we call these functions that are tied to objects or tied to an entity that is required for us to use that function. We call these methods. Okay, so it's a bit of a semantic distinction, but there is a very intentional purpose behind it. So whenever I say, hey, why don't we call the method, what that means is, hey, let's call, like, I must be talking about a function that exists as part of an object, right? So all methods belong to an object, whereas not all functions belong to an object. Some functions can exist independently of anything else. Make sense? Okay, cool. So performance-wise, methods are just functions. The reason why we call them methods is because they're tied to an object. They have an entity, they have an owner that they kind of belong to. Okay, so creating a method. Well, the way we create a function, the way we create a function, hopefully at this, wow, I'm really bad at this. Cool. So the way we create a function is we just write, like function keyword, the name of the function, we list the parameters, we write the curly braces, and we write it very traditionally, right? The way we create a method is literally in the same exact way, except the only difference is now instead of doing it, kind of independently or doing it just kind of in blank space, we basically now have to do what? We have to make it as part of an object, right? Because if I have a method, then it means this method must belong to an object. So therefore, that must also mean that when I create this function, I must be creating it as part of an object. So I think someone yesterday, I think maybe his day or someone asked about like how do we create a function in an object, right? And so today today's basically all about that. So between lines 5 through 9, I have a very simple object called Grace Hopper. I have 3 keys and I have 3 values: Grace, Hopper, and Rear Admiral. Notice how the values are all strings, but as we mentioned yesterday, whereas the keys have to be strings, the values can be anything you want, right? And so today we're talking about, well, what does it look like when we want to have a function in there? And the short answer is, it looks almost kind of like how you would imagine it would look, right? We have a key, which is still the name of the function. And then for the value, it's literally just the function itself, right? Notice how on line 5 there, the function definition, it looks very similar, right? If I ignore the fact that the key is the name of the function, I look at just the value is literally we use the same function keyword we always used. We don't name it because we've already named it, or rather the way to access is going to be by the name of the key. And then we do our open parentheses, close parentheses, which means, hey, here's a list of things we're going to take in, right? The arguments that we're going to take in. And then we do our open curly brace, whatever it is our code block is, and our closed curly brace. So this value here looks like every function we've written so far minus the name. And the only reason for that is because, once again, the name is being stored as the key name. Okay, so the syntax, or this might look a bit strange to you at first. It might take some use to get to, it might take some getting used to. But just know that there's almost nothing different here that we haven't done before in any of our previous workshops whenever we've created functions. It's literally, we're just typing it as a value instead of typing it kind of independently in the beginning of a line. Okay, and once we've created a method, well, how do we access that? Or once we create a method, how do we access that method? Well, it's pretty clear, right? The function or the method is a value in an object. So we access that method the same way we access any value in the object. And the way we do that is by going to the object, in this case, Grace Hopper. Here we're using dot notation. We could very easily use bracket notation here as well. We do dot, and we say the key, right? And when I go to an object and I say object.key, it's going to say, oh, here's the value that corresponds to that key, right? So if I don't have this open and closed parentheses before it, this is going to return back what? Sorry? A lot of mumbling.
Nothing?
Well, no, it's going to return something.
Would it be the string of the function code?
Not quite. Nope, not defined.
It's got its own function.
Right, it would just return back the function, right? If this was a string, this would return. So I'm trying to cover the open and close parentheses here. If this was a string, then when I call object.key, right, gracehopper.rank, it would return ramroll, right? If this was a number, it would return back the number. This is a function, so if I didn't have this here, this would just return back the function, right? Like, once again, right, like, once you understand how objects work, like, everything we're teaching here is actually remarkably consistent. That's one of the things that software programming is actually really good at, is over time, because how people use it, it's actually pretty good at being relatively consistent. So if you understand how to access the value in an object, like, that's it, right? There's no like gotchas or any kind of weird edges to that, right? So this is a function, and so when we just call my method, it'll say, okay, well, as far as I know, you're just looking for the value associated with the my method key in a gracehopper object. Well, the value is a function, so great. So here's a function. Okay, this is once again, I think I mentioned this 3 days ago, but this is where a lot of people get tripped up. How do you invoke a function in JavaScript? Okay, by what? Well, yeah. So the only way to invoke a function in JavaScript is with the open and closed parentheses. Okay, and I'm gonna keep saying it until like it kind of hits you. The only way to invoke a function in JavaScript is to use the open and closed parentheses. This is the part where I think a lot of folks just have trouble, like kind of like taking that word and taking those words and translating it into an actual like kind of like application. If I call gracehopper.myMethod, am I invoking any functions? No, I'm not, right? I'm just saying, hey, here's a function, right? But when I have an open and closed parentheses after it, what I'm saying is, here's a function, and I'm going to run it, right? And that's so critical. And in today's workshop, and also probably a lot more in Saturday's workshop, like, we're really going to test your knowledge of this. And in the interview problems, they're really going to test your knowledge of this, right? In your mind, are you able to differentiate between like a function versus running the function? Okay, because the function is just like, I don't know, it's almost like here's a car and here's driving a car, right? Like, just because you have a car doesn't mean you've driven it anywhere, right? Only by getting in the car and driving it are you actually kind of running it, are you actually doing something with it. So once again, right, this function on line 5, when we create this, is this function being run at all? It's not, right? We're literally just creating a function. On line 11, if I take off this open and close parentheses, am I running any functions? The answer is no, right? Because I'm just saying, hey, what's your value? And you can say the value is a function. It's like, okay, great. But then if I use the open and close parentheses, now when if I read this code, let's try saying, hey, this is going to be like a function, and the next thing I want you to do is run that function. So just whenever you're looking at something, and I'm going to ask you a lot during the workshops around functions, is when I ask you, like, what is that? What I need you to tell me is this a function? Is this running a function? Is this what the function returns? And those three things, like, I know, like, when I ask you, you might feel like I'm being, like, kind of difficult on purpose, but those three things are all very different. And when you're writing software, or rather when you're writing JavaScript, you need to be very, very, very clear on what's happening at each step, because the computer is very, very clear on what each of those steps are, and the computer is going to do those things in a certain order. And if you don't know what the computer is going to do, then your code is most likely not going to produce the output that you want. Okay? So once again, a function is just a thing, right? A function in JavaScript is actually just another implementation of an object. Much like how an array is an object in JavaScript, a function is just an object, right? So if I say, here's an object, you're like, great, let's just look at it, right? It's not going to do anything. Only when I say, hey, function, can you run? Then I'm actually going to run the function, and the code inside the function is going to process or execute or whatever, right? So just to belabor it one more time, a function inherently does not run. The only way to run a function is to invoke it. The only way to invoke it is with the open and close parentheses. Do you have a question, Josh?
Yeah, if you said let x equal gracehopper.myMethod, could you then write x parentheses and then run that function?
Yep, you could. And that's kind of almost exactly what we're doing here, right? Like gracehopper.myMethod is just like, it's a variable that points to this value.
Yeah.
Right? So like, yeah, so like, well, I mean, if we're creating one variable, there's no reason why we can't create another variable that points to the first variable, right? So it's just a kind of this chain effect of how we want to do it. But like that inherently is kind of like the core of invocation, is just like, and the way the computer is going to do this is the computer is going to, like, no matter what this is, let's say this is a number, right? Let's say instead of having a function as a value for my method, I have a number. When I write this, what JavaScript's going to do is JavaScript's going to say, gracehopper.myMethod, it's number 5. Great. Oh, you want me to invoke it? Let me invoke it. And then you'll throw an error. The computer will throw an error at you, right? Because what the computer doesn't do is the computer doesn't like pre-check. It'll just try doing what you want it to do until it hits a wall and stops and can't. So if I change the my method value to a 5 instead of function, I tried running that same code, I'll probably get some version of error saying 5 is not a function or 5 is not executable or something, right? It's almost like it will if you give it a directions, it will blindly follow it up until the point it hits the wall, right? It won't say like, oh, it looks like there's a wall there. I'll stop like 20 miles before, and it'll say, yep. I'm gonna keep going. I hit a wall, and now I'm done. Okay. So once again, this is a function. This is not being run. This is a function. It's not being run. Now this function is being run only when we see the open and closed parentheses. Okay. Cool. Yeah, this is a little bit more of a like a semantic thing. I didn't spend too much time on it. If you just name your functions appropriately, usually you'll kind of cover this. The idea here is that the methods for an object usually kind of describe what you're trying to do to the object. So it's a little bit descriptive, and it usually applies to the object. So what that means is, like, let's say I have a gracehopper object here, and I have a say quote. It will do something that's related to the gracehopper object. It wouldn't do something related to like something else, like completely arbitrarily, like a global variable or something. Kind of makes sense, right? Like I have like if I have a method, that method probably relates to me in some way. It wouldn't be something that relates to like someone else. So, yeah.
Do you know if she's the first person to say that?
I don't know. I know it was in The Godfather, so probably not. But I mean, I could be wrong.
The Godfather would be after her time.
When did Grace? When was she? I thought she was 70s. Was she not?
No, she's 40s, like World War II.
Oh, okay. I lied. You're right. She was in World War II. She did Cobra. Okay, so yeah, so it's probably her before it. Yeah, maybe. Yeah. Okay. So the next thing, this once again, right? This is just nothing new here at all. This is everything that we've seen so far. The only difference here is, hey, guess what? I can have multiple functions, just like I can have any type of key value pairs in an object, right? Except now, well, I'm writing a function. So if I'm writing a function, I pretty much need the full functionalities, right? The full features that come with writing functions. One of which is I need to take something in. And so here, this is just to show you that, yeah, these functions, they also accept arguments, right? And we write and we name those arguments the same way we've done it for every other function we've written so far in this class, this cohort, right? Nothing different, same exact thing. And now this takes something called here. When we call it, we also do Grace Hopper get h to the function. We invoke it and we pass in something, and this thing becomes here, right? So very, very standard. This is how every function we've seen so far in JavaScript works. Just to further prove the point that that is a real function with all the fun things that a function can do. Okay. So in this part, so this and the next I go together, right? So in this case, we have another function called greet, takes in a name. So when we call greet, we do .greet, we pass in a name, and then on line 8, what we do is we console log out, hi, name, I am Rear Admiral Hopper. But the idea here is that sometimes it may be a bit redundant, or rather, the redundancy comes from the fact that, like, hey, here I'm saying I am Rear Admiral Hopper, but Rear Admiral and Hopper actually both already exist in the Grace Hopper object. And in in programming in general, there's this idea that one's called, like, you might have heard called dry code, like DRY, don't repeat yourself. So anything you write, you should only try to write it once, and every subsequent time you should try using what you wrote the first time, as opposed to writing it over and over again. The other thing is programmers tend to not to like what we call these are like kind of like magic strings or maybe magic numbers, whatever. Magic as in like they're kind of hard coded and no one really knows where they come from. So it's like, oh, I am Rear Admiral Hopper. Where does where does it come from? Like, if there's a way to point to something that already has that value, we should do that instead. So another way to write this is that, which is to say, rather than literally write out I am Rear Admiral Hopper, I can actually just say, hi, Karen or Gabe, I am, and then look how we have a Grace Hopper object here. Just do gracehopper.rank, and then gracehopper.last, which is Hopper. Okay. So now we're actually making use of existing key value pairs in our code, and more importantly, now when we look at this code, we know this is the same Rear Admiral Hopper that belongs to this object, as opposed to maybe this is another Rear Admiral Hopper, right? And this now is kind of starting to get this idea like, hey, this object is kind of self-contained. Everything in this object relates to this object specifically. Okay, yeah.
Do those commas act as plus signs?
Those commas act as plus signs, except they interject space as well. Yep. Okay, so this is so we're going to talk about something called this, THIS. It's really hard to talk about in like verbally, so just bear with me here. Hopefully you can pick up the distinction of what I mean when I say this versus just like colloquially like talking about things like this. Okay, so you know how methods are functions that are tied to an object, right? Methods are functions that are apart, right? They're the value of an object. Well, what this keyword, THIS, it's also, it's not a reserved word in the way we think about it, because you actually can set this, you can do like this equals, but the point here is this comes built into JavaScript, and whenever you use this, what you're referring to is the object to which this particular function is tied to. Okay, so when I do like gracehopper.greet, right, and I just do my name and say, hi, I am gracehopper.rank, I can actually just write this.rank, because when I write this, what the computer's going to say is, okay, you're writing it in the context of this function. Great. Who does this function belong to? Oh, it belongs to this gracehopper object. Therefore, this is equal to the gracehopper object. So when I do this.rank, it's almost like it's almost like a variable name that that is synonymous, or rather, that is a representation of Grace Hopper. So this dot rank is the same as Grace Hopper dot rank, and this dot last is the same as Grace Hopper dot last, because once again, this function here belongs to the Grace Hopper object. Yeah. Julie?
That only works if it's within function. As soon as it's outside, this would refer back to that particular.
It would. It will. If you use it outside of a particular, like if I just wrote it on the first line of the page, this most likely will refer to some variation of the global scope, the global object. So one of the things you want to be careful about is this is going to always exist. You just, a lot of times you don't care about what this is, except in like very contained settings, right? So in this instance, like we care about this because we want to get access to the Grace Hopper object. On line 3, if I wrote this dot whatever, or just even this, and I console log it out, it will say, this body of code is part of the global object, or the window object, and it's not really useful to us. So, but yeah, so we don't need to worry about it too much. We only worry about it when we're trying to use it in context of functions and getting a reference to the parent object. One of the things you guys learned probably, or one of the things you all probably learned last night was, hey, if I have two objects and I do object 1 equals object 2, I'm going to get back false. And we'll talk about why that is in more depth tomorrow. But if I do this equals Grace Hopper, I'm going to get true, because they are literally pointing to the same exact thing, right? They are literally representing the same thing. It's literally like, if the reason why this is sometimes hard to teach is because you might see, like, if I write this on line 9, I could also write this on line 12, and the this at line 9 is different than the this on line 12. Right? It's like someone saying, I am here, right? Like, where's here? Well, if they're saying it when they're in Montana, here's Montana. If they're saying it when they're in Texas, they're in Texas, right? But in both cases, they're saying, I am here, right? So when you see and you want to write this, you need to figure out exactly where they are on the page and what they're referring to, because you could have two subsequent instances of this, and their values could be completely different, right? Because this is just referring to where you are at that moment, or rather, where this is being used. Yep. And then here, if I just do something even more blatant, and I say okay, return object equals Grace Hopper dot get this. Get this is a function that returns literally this. If I console log out the dot first property, I can see that I get Grace. And then once again, if I do return object equals Grace Hopper, I get back true. This slide, a lot going on here. If you get confused today, maybe look at it a bit more in depth. This slide basically has everything. Like, if you understand this slide perfectly, you essentially understand functions perfectly. And what I mean by that is, so we have this idea of an object, sure. We have an idea of this, right? You understand that this is tied to the object that the function is tied to. Cool. But more importantly, a few really important key highlights here, right? The first one, Grace Hopper get this. That's just a what? It's a function. Nothing's invoked. It's just a function. It could do anything. I don't know yet. When I invoke it, the actual code for the function runs, right? And what does this function do? On line 8 there, we see it returns something. Okay. Once again, return. What does the return do? Return does basically two things. Return gives back a value from the function, and then the return also ends the function. Right? Every function can, by definition, only give back one thing. And so the function is saying, well, once I give back this one thing, right? If I use an analogy of like the teacher, right, and the final paper, it's like once I turn the final paper, it's like nothing else I do matters, right? So like once the function returns something, the function also terminates. So I know in a lot of the code that you've all written, a lot of times you're like, oh, let's loop through this for loop and let's return something at every single iteration. Except what you find out very quickly is that, hey, we never make it past the first iteration, right? We hit the first iteration, we return something, and not only does the rest of the for loop not run, the rest of the function doesn't run either, right? So return gives something back, okay? When a function gives something back, it's like I'm handing you like an apple, right? Or I'm handing you something. If you don't receive it, I'm gonna let go, and the apple is just gonna fall, I guess, into like the floor or into the abyss or whatever, right? So when a function returns something, we have to kind of say, oh, great, let me like take it and let me either do something with it, or more commonly, let me store it somewhere. Okay, so here, gracehopper.getThis is going to return anything really. We'll say this or a number or anything, and we're saying, hey, let's capture that value in this variable called return object. If we don't have that let return object equal, right? If we don't have this side of line 12 here, and we just invoke gracehopper.getThis, this function's still going to run. This function's still going to give us back this, except right after we give it back, we don't store it anywhere, and so we kind of lose it, like in the void, in the computer void, right? And so this is, and so when I say like if you understand this slide, you actually understand functions perfectly, or functions are objects, not perfectly, but to probably enough of a good state that you can pass like the interview comfortably. Is not only does this have function, the distinction between a function versus invoking a function, it also shows basically like a very simple example of how return works and how it's very important that we capture the return value somewhere. Just by walking around, I know a lot of times when I kind of see the workshop problems you all work on, a lot of times you guys invoke a function where you have a return, but you don't like you're not quite comfortable with how the return's working. Like you're just like, oh, I'll just put a return here, and I hope to God that just does what I wanted to do, right? And once again, computers, they don't operate on prayer. They're highly logical machines. Right? So if you ever get stuck on return, come back, look at this slide maybe, and just note that like this seems simple, but like understanding how this return gets here and then how we have to capture that value is very critical. This is the same reason why a lot of times in your code in the arrays, people will do array.slice, 0, 3, and they're like, what happened to my array, right? Like I sliced it, what happened to it? And what you don't realize is, well, array.slice gives you back a brand new array, right? It returns a new array. So if you never store that array anywhere, guess what? It's almost like asking hey, can I buy like a scoop of ice cream? And then when they hand it to you, you just let it drop on the floor. And then you're like, where's my ice cream? It's like, well, they gave it to you, you just didn't do anything with it, right? So knowing how return works is extremely critical to basically writing any code that has more than one function, which in the real world is going to be all code. Cool. And that's pretty much it. We're going to go through maybe one or two examples here. And I'll blow through this fairly quickly because I wanted you guys to start the workshop. They'll do a much better job of helping you get experience. We have an object called calc. Num1, num2 is just random numbers. We have two functions, a sum function and a difference function. Both functions take in nothing. And then both functions return something, okay? Oh, also, return versus console log. Console log doesn't really matter, okay? You can say, well, my code is console logging out this. It's like, great, right? The analogy I gave was kind of like, it's like when your professor asks you to turn in final paper, and you give them like very nice updates, like, oh, I worked so hard on this, or yeah, I made a breakthrough. It's like you can give them all the updates you want, but until you give them the paper, it means nothing, right? So console logs really mean nothing. So we have to return this, right? So this returns this .num1 plus num2. This returns this .num1 minus this .num2. And here what we do is we do calc.sum, right? We invoke sum, and we say what's this .num1, which is 20, plus this .num2, which is 30. So we get back 50, and we console log that 50 out here. Notice how here on line 13, we reset num2. We say calc.num2 equals 15 now. And so now when we run calc.difference, this .num1 is 20, this .num2 is now 15, right? So every time we invoke that function and we say this .whatever, like at that point we look to the object and say, what is your latest value of whatever this key is, right? So basically what it's trying to say that like, you know how like scope is created once when you create the function and it kind of stays that way? This is the opposite, right? This is going to say, hey, whenever you use me, I'm going to go back and check for the latest and greatest updated version in case you changed it. Okay, so here when we do count.difference, we do this dot num1. Oh, okay, still 20. Well, whatever, doesn't matter. This dot num2. Okay, 15. And then we do the math, right? So this, whenever we use this, we basically look to the object again for the latest value. And the, kind of covering our bases here, this is an incredibly complex topic. We use it here just to show you, a very common, like, kind of rudimentary principle of one application of this. This is extremely complex to the point that, like, I still have, like, certain areas where I can't, like, verbalize it or understand it, like, really, really, really well. So don't think that, like, this is all there is. Like, there's a lot more to this. Cool. All right. That was, like, so punnable. Okay, so that was pretty much it, right? We just basically walked you through how to use functions in objects, right? We could rename this section like functions in objects, because that's literally what we've done, right? The function itself does not change. It's just now we're just using it inside of an object. Any questions?
Great lecture.
Great lecture? Awesome. Not a question, but I appreciate it. Okay. Okay, 7:20. So you all have, oh wow, almost 2.5 hours. So don't burn out too early. I will send out groups now.